Hello, welcome once again. This is that Qinsy guy, and today I'm gonna take you through on the Gyro interface on Qinsy. Yeah, um, and then I'm gonna show you a small demo, quick demo on how to interface Gyro on Qinsy. So without wasting much of the time, I'm gonna have my slides set up. I'm gonna open it right now, and then let's quickly go through the slides, and then I will. Okay, so this is the Gyro we have been working with, and this is the interface from Qinsy. And so I'm going to take my time to see how I can possibly explain each of these items right here. Okay, so the first thing there is the Gyro observation name. This is simply the identifier of the Gyro observation in the database. So the best practice is to name it clearly based on the sensor or role. So location here refers to where the gyro is mounted on the vessel. Okay, so you name here, and then location here has to do with the location where the gyro is placed or mounted on the vessel. So we have observation parameters, which is the core setup of the setup. Then we have the type, we have the true bearing, we have bearing which is true. This tells Qinsy1, the gyro outputs through heading, not magnetic, not relative bearing, and this is almost all offshore gyro systems use through heading. And of course for the unit is usually in degrees. Heading is measured in degrees, range between 0 to 760 degrees, and of course clockwise from north, and this must match the sensor output format. And then we have what we call the RWSD, or standard deviation. This defines how much Qinsy trusts the gyro data. Okay, of course lower value requires high confidence, and higher value means low confidence. When it has to do with this standard deviation. Standard deviation has to do with how accurately we're able to measure the values during a calibration. Then we have for example for fiber optic gyro we have 0.1 to 0.3 degrees. For mechanical gyro we have 0.5 to 1.0 degrees. And then Qinsy uses this during computation and moving. Then we have the fixed T minus O, is constant offset. This is a static heading offset used to correct a known constant misalignment. Example, gyro installed 1.5 degree off vessel center line. This is usually populated after gyro calibration. So these values are actually populated or are gotten after the gyro calibration. Then we have the variable C minus O. This allows dynamic correction used when offset changes slightly, rarely used in standard offshore operations. So most projects rely on fixed C minus O and not variable. Apply C minus O offset first. When this is ticked, it means apply offset and then apply scale factor. So when they apply C minus O offset, this controls calculation order, especially calculation. This is the recommended and standard option. Then we have the scale factor, which in most cases is left at 1.0, used when the gyro output is slightly scaled incorrectly. 1.0 means no scaling, rarely adjusted in real objects. Real projects leave at 1 unless manufacturer specifies otherwise. Then we have slot identifiers, very important but often misunderstood. Slot number 1 and 2, these are used when multiple sensors share the same data stream, or one system sends multiple observations. Examples, we have dual gyro in one data stream or integrated INS system. So if you have single gyro, single data stream, leave slot IDs blank. When slot IDs are used, you need to know when they are used and when to use them. You fill slot IDs when one interface provides multiple headings. you must tell Qinsy which one to use. For example, slot 1 is equal to gyro A and slot 2 is equal to gyro B. And so these are all the items on the interface when you are trying to interface gyro. In most cases, the TSS gyro on Qinsy. So let's see how this is actually done on Qinsy. So we'll head to the Qinsy setup and then open this one right here. Okay, and then see. However, I already have one existing right here, but I can show you how it's done. Okay, so I'm going to click on my vessel name, right click, new system. Now write this gyro, and the type here is of course gyro compass, and then driver. So you choose appropriate driver for the particular gyro you're using. In most cases, we have Teledyne TSS, Teledyne TSS. Let's see, Teledyne subsea trading, subsea Teledyne. So you may not be able to find these here because of the version of Qinsy I'm using, but then typically you need to find the particular driver for the system that you are using. Let me see if I can use something else. Okay, so for example, if we use this one here, okay, so this means it's going to be a network connection where you put the port number. If you have one that has to do with a serial connection, then you may need to put in the baud rates and everything that has to do with the system. So for example, if you take this, so assuming that is the driver for the compass, then you need to put in the port number, the baud rate, maybe baud rate maybe like say 19200, top bit is 1, start bit is 8, parity is none, and then click on next. And so here is where you now put in this value. So this fixed C minus O is the value populated after calibration. Okay, and so finish. We click on finish, and that is how you add Gyro to Qinsy template database.